Hi everyone. Okay, so what I want to do right now is take the opportunity to answer the questions that you were given during your breakout group just now, okay? So before we begin with the answers to the questions during the breakout group, I just want to remind you of the different options that you have for measuring out 100 centimeters. So if we're saying that we want the release height of the ball to be the same for each trial, we are going to use a meter stick. And of course, some of you don't have a meter stick at home, you have a yardstick. So I want to remind you of the alternatives that you have. A meter stick is 100 centimeters tall. But if you turn it around in inches, we talked about this in class, it's 39 inches. So 39 inches is the same thing as 100 centimeters. If you have a yardstick at home, which most of you probably do, it's a common item to have in a household, you're going to notice that it's a little bit less than a meter. And that's okay because you're using the yardstick for all 24 of your trials. You would just need to make a note that your release height for your ball is actually 39 inches and not 100 centimeters, okay? So this is one alternative. If you do not have a meter stick at home, you can use a yardstick. Remember that we gave you a printout calibrated of a meter stick already on Schoology, so you should have that ready to go today, and you can have it taped onto the surface, onto the surface of a wall or a door if you want to, just because it's one less thing that you have to hold on to.
Can I ask a question?
Yes, you may.
So, Ms. Hoyson, I see on your door that your taped on meter stick there is not touching the ground.
And you'll see why in a moment. That's a very good question. So what about if you do not have this because you don't have a printer at home, or you do not have the yardstick or the meter stick? So the other option we gave you was the string. Just take a string and make it a specific length, and that is your template. That is your release height for the whole entire 24 trials. So the bottom of the string would be touching the bottom of the floor, and you would hold it or suspend it in air, and then you would put the ball at the top of the string, and this would guarantee that the release height of your ball for every trial is the same. Many of you have this option at home. You have measuring tape. So remember, we said 100 centimeters is the same thing as 39 inches. So if you have measuring tape at home, you can measure out 39 inches, and you can put the little stopper on it, and there is your homemade meter stick. Okay, so you can take the ball and you can release the ball from 100 centimeters. One last alternative. Some of you have measuring tape at home like this because you sew. So this is actually measuring tape that is in the metric system. It's calibrated in the metric system, and when you look at it, it actually is 150 centimeters. So it's a little bit longer or taller than a meter, but then you would just have a higher release height for all of your trials. But again, you would use it as the same way that you would use the string. Many of you will have this at home because you have people in your family that sew, and most likely it would be measured in inches, so you most likely will have measuring tape that is a full length of 1 yard or 39 inches. But you'll know because you just have to look on the actual measuring tape and it'll tell you, okay? So the first question was, what is the release height? And why is the release height always the same? So I hope you realize we just answered that. It really depends on the equipment that you have at home. Some of you will truly have 100 centimeters as your release height for all 24 trials. Some of you may have 39 inches, 36 inches. Did I say that correctly? Yeah, because a yard is a little bit less than a meter, so if you're using a yardstick, your release height is 36 inches off the ground. So again, it's going to depend on the material that you're using as to what your release height is going to be. All right. What about number 2? How many trials are you doing per surface? You're going to do 3 trials per surface with 8 surfaces, so that's 24 trials. But we want you to know that we are going to expect you to probably do more than 24 trials because you will have some missed trials, right? So for example, if you're going to take the ball, I'm going to move over here. Sorry, I just changed my mind. If you're going to take the ball and you're going to have it drop from 100 centimeters on maybe a table in your kitchen, if that ball, and you're counting the number of bounces, and that ball bounces off of your surface, you will not be able, that's a mistrial, because you know there were a lot of bounces left in that ball, and you were unable to count them. So this is what we mean by be prepared to do more than 24 trials due to mistrials, okay? So if your ball bounces off of your surface and actually leaves your surface before the bounces end, then you are going to need to redo that trial. And as you do more and more trials, you will get better at angling and aiming your ball correctly so that you can actually have it hit the center of the surface and stay there on the surface and continue to bounce the whole time. If you are doing rebound height, you don't have to worry about that. You just need one hit, right? Because you're going to videotape with your phone the rebound height and then stop recording. You don't need to worry about every other consecutive bounce at that point. All right, I'm gonna move back over here. Thanks, T. I'll leave this here.
Want your golf ball?
That's okay, I've got others as a spare. All right, where do you, this is number 3 from the breakout groups, where exactly do you place the bottom of the meter stick? So this is something that you need to be aware of. If you are using a yardstick or a meter stick, and let's say I'm bouncing, this is my surface. I'm just taking a crate and I turned it upside down. You cannot put the meter stick on the floor because at this point, the ball truly is not 100 centimeters above the surface. So what you have to do is you need to remember to place the meter stick or the string, the bottom of the string, the bottom of the measuring tape, or the bottom of your paper version of your meter stick. The bottom of it should be touching the surface because the constant variable in this lab is the distance the ball is released from the surface that it will collide with, right? So if you are doing a bed of sand, you do not dig the meter stick into the sand because you've just decreased the release height. You want the bottom of the meter stick to actually be just resting against the surface of the sand. If you're using a lid to a container, again, if you're going to have it lid up, then you would just place it in the lid. You are truly saying that the ball is 100 centimeters above the surface that you are bouncing the ball on. However, if you choose to use your surface as a lid, but it's going to be face down or lid down, in this scenario, you do not put the meter stick or the bottom of the meter stick on the floor, you put it on the surface directly, okay? Same thing with a textbook. You're gonna put it not on the floor, but actually on the book itself.
It's kind of like when you were doing measurements for Crash Lab.
That is correct.
Wow.
So, what senses, question number 7, what senses are you going to use in this lab when you run all 24 trials? So hopefully your teens realize that obviously you're going to watch the ball, but don't just watch the ball, watch the surface. Look and see how the surface is reacting as well as how is the behavior of the ball changing. You're also going to use your ears. You're going to listen to how the surface responds. You're going to listen to how the ball sounds for every consecutive bounce. The other sense that you are going to use is touch. And this is a requirement for all 24 of your trials. This is why you might go above 24 trials, because this is something you might want to do separately, so you don't have to worry about measuring and counting and timing, and then also put your hand on the surface. So you might want to actually do a 4th trial for every surface, and that 4th trial is the hand touch. So why would we want you to touch the surface while you release the ball? So again, that's a situation where I'm going to ask you, if we release the ball and it bounces and collides with the surface and I'm touching the surface during collision, why is that an important piece of data to collect? And then how do you calculate, I believe this was number 8, how do you calculate percent rebound height? Okay, so percent rebound height we're going to do over here. So again, you have a meter stick, assuming that your release height is 100 centimeters, right? So when you release it and it hits the surface and it rebounds, right? We want to know, well, what percent of that original 100 centimeters was your ball able to rebound to? In other words, out of 100 centimeters, how high up out of that 100 centimeters was the ball able to rebound? So out of, when you were probably 4th, 5th grade, you learned that those key words give you an indication of what function in math you should be using. Of represents division, right? So if we say that the ball drops from 100 centimeters, hits the tabletop, and rebounds to 65 centimeters, we would say that it was able to cover 65 centimeters of the original 100 centimeter release height. So you are going to be doing division to calculate percent rebound. It would be how high it rebounded divided by the original release height. But it says percent rebound height, correct? So to turn your value or your answer into a percent, you would multiply it by 100, correct? And that would turn your final answer into a percentage. Now, most of you are seeing, wait a minute, I wouldn't need to do that if it's 100 centimeters as the original release height. But some of you don't have 100 centimeters as the original release height. Some of you have 36 inches as the original release height because you're using a yardstick. And let's say it went up to 22 inches. So the rebound, again, if you're using a yardstick and you release it from 36 inches above the surface and it rebounds up to 22 inches, it would be 22 divided by 36. Take that value, take that answer and multiply it by 100, and that will give you the percent rebound height. Okay? Thank you.